Friends, welcome back. In today's video, we will be watching how we can measure the seasonal variation in time series, or we'll see actually different methods with the help of which we can uh, calculate the seasonal indices. Because understanding seasonal indices in a time series is important for a business manager because it will decide different aspects of decision making in business. In course of the presentation, we will see actually how it works. But let us start with the presentation. Before we go to the next slide, let me draw your attention towards the graph which is at the end of the slide in the lower right corner. You will find that this is an example of a time series where there are some zigzag curve going on from one point to the other, but with a regular pattern in it. You will find that it is coming down, then going up, then coming down and going up. These peaks and troughs that are appearing in the time series is appearing at regular intervals. This is because there is some seasonal impact on the time series, which is actually allowing the time series to vibrate in a regular fashion. So the irregularity that you see in the time series is appearing in a periodic manner. And this type of time series indicates the existence of a seasonal variation in it. So let us look at this, how to identify the seasonal variation and how to compute it in quantitative terms. So let's get started. In this presentation, we will try to understand the concept of seasonality. A little bit discussion already we have made about. We'll understand what are the different ways in which seasonality or seasonal indices can be computed. There are some very popular methods of computing seasonal indices, out of which you see in details about the method of simple average and the ratio to the moving average method. Ratio to trend method and the link relative method, these two methods we just make references and we will try to understand how it work. But numerical examples will be concerned with number 1 and number 3, that is on simple averages and ratio to moving average. In this process, we will also see the relative merits and demerits of the work, and then we will actually look at some of the applications of this method in business decision making, that once we know the seasonal indices, how we can use it for decision making. That is what we will also see in this presentation. So let us try to understand this. Already we know that time series is affected by some components. There are different components which influences your time series, out of which the first and the foremost one in which generally our attention lies is the long time trend or the secular trend, which is called as denoted by T. Means we want to see that in our time series, in the long run, what is actually happening in the time series, whether it is over a large period of time, whether it is increasing, whether it is decreasing. That particular thing is denoted by T and is called as the trend. But in this presentation, our concern is not so much to identify the trend, but our focus is on understanding the next one, that is uh, seasonality of the time series. Seasonality of the time series is a regular but periodic fluctuation of a time series generally happens within a year. So the season has an impact on it, and we have heard about terms like uh, off season, season. That means some of the aspects that we see around us have a specific season where there is a boom and a specific season where it goes down. So if such things are affecting your time series, so for that actually we require at least monthly data or quarterly data. Quarterly means 3 months data. We want 3 months compiled data, or monthly data. It is even better, monthly data. If you have weekly data or fortnightly data or say daily data, it is even more better. The more you dilute or more you go uh, to the lower level of data, that means more detailed data, better it is to understand the seasonal fluctuations. But at the max, you require quarterly data. If you have half yearly data or annual data, in that case, you cannot understand or cannot quantify seasonal variation in the time series. Well, there is another type of time series whose growth or fall is not quite predictable. It appears generally within a period of 5 to 15 years. Such a type of fluctuation where the time series goes up and come down within a span of a large time period, which cannot be predicted like that of the seasonal fluctuations, is called as the cyclical fluctuations. It has nothing to do with the season, but because of different factors associated with the economy or whatever you are studying, these type of cycles come into act. Uh, these are not so much predictable, but you know that within a period of 5 to 15 years it might appear. Like you see, economy, we often hear about recession. So recession keeps on coming, but the time of coming is a gap of within a gap of 5 to 15 years it comes back, where people lose the job, economy goes down a bit, and then it recovers and once again takes its normal position. So these type of fluctuations are called as cyclical fluctuations, which influences time series. And lastly, we have the irregular or random fluctuations, which is totally unpredictable and is influenced by some factors. Because we have seen many things came to a halt during the corona period when we had in 2020 we had the pandemic appearing, and which was not predicted earlier. Suddenly, all production, economy came down, share market went down. So such things influence, such random fluctuations influence our time series. Maybe in an organization there is sudden lockdown, sudden huge gigantic failure in the machines which took a lot of time to recover, etc. So such fluctuations actually influence the production, income, etc., profit of the organization, but such fluctuations cannot be predicted earlier. They are random, abrupt, but might appear sometimes when we watch a time series for long run. So these are the four components of time series. So in this particular presentation, we will understand seasonality. Already we have been discussing about seasonality. We'll basically understand how to quantify seasonality, and quantification of seasonality is done by seasonal indices, computation of seasonal indices based on the time series data. And there are different methods of doing that. We will cover four different methods, and two methods will go to the detailed calculation. Now, why shall we measure seasonality? First is that if you know the seasonal variation in demand, supply, etc., then you can plan your inventory, you can plan your stock, how much products are to be stocked before a season. When is the lean season, when stocking too much of the goods which you are marketing or which you are concerned with may be detrimental to your business. So, this type of things actually a important aspect of seasonality is to understand how you are going to manage your inventory. Next, we have workforce planning. In workforce planning, we need to actually understand the peak season, because in peak season, we might require the services of a large number of employees. So temporarily, many employees might be recruited in order to negotiate the impact that will fall during the season, during the peak season. During the lean season, you might not require so much of staffing. So you may actually either stop hiring your staff or transfer your staff to other departments or other sections of your organization where there is a demand for workforce, or you may totally scrap their job. Probably that is the way in which temporary people are recruited. That means temporarily they are recruited for a period of time. Once the peak season is over, they might actually move away. And even in, we have seen that in many places during the peak season, some people change their profession because they actually perform in a particular sector during the peak season. Once the lean season comes, they have some other things to do and they shift themselves to those type of work. So this is workforce planning, which is actually an impact of seasonality. Then marketing your budgets, allocating and spending during high demand periods, because when the demand is high, you need to keep everything ready. So you might require to spend more money, invest more money. Well, you will get the return as well, but you need to keep the money ready for investment. In financial forecasting, seasonality actually helps us to predict the cash flow and revenue. of a particular organization. So you can understand that what will be the amount of expenditure which will be required. So you understand seasonality, then you can forecast the financial requirements of your organization. And production scheduling is very important because at a different point of time the demand varies because of the season. Now when the demand increases, at that time you cannot produce because it will take time for the produced products to reach the market. So you have to catch the demand period, high demand period, so that production should take place before the high demand period appears or the peak season appears. Before the peak season appears, you need to actually uh, complete your production process, and your uh, amount of inventory should be ready to face the demand. So accordingly, production should go up. Production should go up before the season, not during the season, because during the season your product should be in the market. So this is why production scheduling is very important, and then we keep an eye on the seasonality to understand when the production should go up and by how much, what might be the expected demand. So these are some of the applications of seasonality in business. Well, there might be many other applications as well. Now let us start to understand the method of computing seasonal indices one by one. First, we come across a method called as method of simple average. Now, to compute the method of simple average, first thing is that the data requirement for this, obviously, we have year-wise data for several months. That means, say, I have 5-year data and all the observations are monthly, at least monthly, then it is good to understand. Okay. Then we have, say, 5 years. So 5 years, there are 12 months. So I have data for 12 months and for a period of 5 years. So not necessarily that you require data from starting from January onwards to December. That means entire calendar year. You may start in between. Say you start in 2020 in the month of September. Well, we can do with this, and you may end up at November of 2025. So that much. So some months might be additional, etc. But you require data for few years. Otherwise, studying 1 or 2 years will not give you the exact seasonal impact. That means your estimates will not be good. So, and you cannot go much back to the distant past, because in distant past things were different. So, obviously, we require the recent years in order to understand the seasonality, but we require for several years. So, at least if not monthly data, you require the quarterly data. So, what are the steps? First, arrange data by years and quarters or months. Calculate the average for each quarter across all the different years. Okay. Calculate the overall average of the data. And now the formula of seasonal index is quarterly average or monthly average divided by overall average into 100. The whatever index value we get, that index value can be interpreted to understand what is the demand of the product in that particular season. Let us try to understand this with an example. So here we have an example. You can see in the screen that there are data for 3 different years, and from January to December, that means complete calendar year data we have. Now what we are to do, first thing is that we actually calculate the average. That means average of this is 12, average of 12, 15, 16 we write over here. Then average of 11, 14, 15 we write over here. So these are the monthly averages. So monthly averages. So if you, even if you look at it, you see that every month average is not same. For example, you see some jump here: 15.33, 15.33, 15.67, 16.33, and then there is a downfall. Well, so there are some, they are not all equal. So this is next what we do is we calculate the grand average. That means we add up all the averages and divide it by the number of months. That is 12. So you can see here, you can see here is 12. Okay, and we have taken the average. This 14.33 I have written here, 13.33 I have written here, last four, dot 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 14.67 divided by 12. So I get these as like 13.6625. Now for seasonal indices, what we do is that, for example, for January, we actually do that we divide, because January value is 14.33. We divide 14.33 by 13.6625 and multiply it by 100 to express it in percentage. That means, so what we do is that we come here. So we have like 14.33. This value is coming from this part divided by what is the grand average? 13.667. Sorry, 13.6625, not 7625. Multiply by 100. So once I multiply by 100, I get it as 104.80. The next value for February, what I do in February, my value is 13.33 divided by what is the grand average? That 13.6625, and multiply it by 100, and I get the value. So that value comes out to be this 97.57. So here you see, you get the monthly indices of all the months across this. Now let us try to understand how I can interpret this and understand what is the seasonality. Let me take a different colored pen. I think white will be more visible. Okay. So I have this. So here you check those values which are more than 100. For example, this is more than 100. This is more than 100. This is more than 100. This one. And then I have this. So these are the months when there is a huge demand of the products, because here index is going up more than 100. This is increasing by 12% of than the average. When it is 100, that is your average value, average demand. This is 12%, this is 14%, this is 19%. How I am computing 19%? 119 minus 100. So this is approximately 19%, and here it is 7% more than average. So basically, this is your peak season. This is your peak season. And in December, January, that means in winter also little bit more demanded than what is the average. That means your basically your peak season is during the summer, and also during winter, extreme winter like December, January, you also have more demand than natural. So these are the time periods where you need to stock more. Well, I may not read much to January and December, just little bit above the average, but this is the period definitely which is the season here, and there is a huge demand of product. So inventory can be managed. You require to stock more starting from the month of, so this is February, this is March, this is Feb, this is March. So from your April, it start April, May, June, July. April, May, June, July. This is the period when your sale is boosts up. So you need to improve your inventory. Earlier, you have to produce things so that you can actually tackle the peak season. This way, you have to plan everything. So with the help of these seasonal indices, we are able to identify the peak season and the lean season of a time series. So this is the method of simple averages. Let us look at the merits and demerits of the method of simple averages. First merit is that it is simple to understand and compute. Second merit is that no complex calculations are required, because calculation is very simple. Even with a handheld calculator, you can do it very easily. Good for preliminary analysis. So when you want to have a mild analysis, then you can go. Suitable when trend is absent. I will discuss it little bit. Along the demerits, it ignores trend component. It is not suitable for a long term series, because in a long term series generally trend is visible. So in case there is some trend in the time series, then this method shall not be applied. Can give misleading results if there is a trend, if a trend exists, less accurate than other methods, because it is very simple. Let us try to understand what is the meaning of trend here. Let us take this. Let suppose we have a time series like this. So I think my pen color is white, so it is not visible in a white background. Let me take a black color pen. So suppose I have a time series. This is my y-axis, and this is my say x-axis. So I have here this side I am taking time, and this side is production of an organ production. Now what happens? My time series is somewhat like this. So you see these peaks and troughs, they are coming at regular intervals. Okay. So there is seasonality. Also, one thing is visible, that we are starting from here, going up but coming back. Until the end of the time series, we started here and we ended up here. So if you connect them by a straight line, you find that there is hardly any trend. It has almost become constant over a period of time, or it is not very much visible. In such cases, method of simple averages is actually suggested. But if you have a time series like this, suppose this is your y-axis. Sorry, the straight lines don't come with this pen. Well, just one sec. Okay. Now, suppose I have a time series. The time series is doing like this. Now here, if you look at the time series, you see at regular intervals, we are getting peaks. We are getting a peak here also. We are getting a peak here. So at regular time intervals, there is a peak, but there is a trend also. This time series is showing an increasing trend. If you draw a straight line through the points, you find that it is showing an increasing trend. Along with the trend, there is seasonality. Now, such complicated time series where there is a trend and there is seasonal impact as well, in that case, method of simple averages is not applicable. It may give you some absurd results because over the months it will show an increase, not because of seasonality, but because of the existence of trend plus seasonality. So, this might take you to some confusing results. So, as per the understanding of this, as per this understanding, we actually leave the simple averages, assuming that it is a good method to understand and compute, and very quick results are required. Then we can do this, but more applicable to time series of this pattern where there is no trend but there is seasonality. But in case there is trend as well as seasonality, then we have to look forward towards other methods which we will be covering in this presentation. Next, we come to the ratio to trend method. To measure the seasonality, when there is a clear presence of trend in the data, then we use this method. Earlier, we have seen that in the method of simple averages is more successful when there is seasonality in the data set, but there is no trend. But often we come across time series when there is a trend in the data set, and in addition to the trend, there is a seasonality also. So basic purpose of this method is to determine trend values using the method of least squares. Express the original data as percentage of the trend value. So we first fit a appropriate equation, either it's a linear equation or quadratic equation depending on the time series, and then we express the original data, that means the observed data time series data that we find with as percentage to the values which are obtained from the particular equation, which we called as the trend equation. And then we express the data as percentage of the trend values. So we take an average of these percentages for each of the season, and we need to adjust this a little bit because of to obtain the adjust these averages to obtain the seasonal indices. So these are the few steps. We have the data of time, and then the value of the time series. Then based on that, we fit a appropriate equation, maybe linear, maybe quadratic, maybe exponential, etc. And then we find out the trend value. So we have in one side the original data set, and we have the trend values. Now this original data is expressed in percentage of the trend value. So identically, if the accuracy of the model or the trend that is identified from the equation, if those values are very perfect to the original values, this ideally this proportion or this percentage should be equal to 100, but it does not happen to be so, because when we identify from a regression equation, linear, quadratic or exponential, there will be sometimes overestimation, sometimes underestimation. So this percentage will sometimes go above 100 and go below 100. This average is later on done for each of the season, and then we get the adjusted seasonal indices. So this is the how the method works. The method is computation a little bit clumsy compared to what we have seen in the earlier method, but the thing is that it can deal with trend also. So very quickly, let us look at some of the merits and demerits of this method, that is ratio to the trend method. First merit is that it is specifically designed for data in which a trend is present. This trend may be an increasing trend, decreasing trend, or some other type of trend, initially increasing and then decreasing. Whatever be the trend, this method can actually take care of this. It is more accurate than simple averages. It clearly separates the trend and the seasonal effect. So the clearly separates, it is different to the from the trend method, and the seasonal effect are actually differentiated using this method. And this can also be used for forecasting. Since we use the method of least square to fit an equation, so we can go forward and do the forecasting also, and find out that how the seasonal trend might vary over a period of time. The demerits of this model is that it is computational clumsy, because first take the data set and then identify the trend. You have to feed the appropriate equation. Not necessarily always the linear equation will give you the appropriate trend. You may have to look after quadratic, cubic, or exponential trend also, to find out which one is the best fit. So there a lot of computation is required. And manually it will be difficult to handle. Once this is done, then we assume that, okay, well, sensitivity of the trend and specification errors will definitely be there. So this makes the thing little bit clumsier. But the thing is that these days all the computational aspects are handled by software packages, and those software packages which are actually equipped to work with time series data has subroutines which can handle ratio to trend method. So all these things are done almost automatically. So these well can be recommended as a tool, provided that you don't have to do the computation manually. We don't see the computation because this computation is mostly software based. We go to the next method, and this is probably the most popular method of identifying seasonality in the data set and computation of seasonal trend. That to This actually eliminates the trend, and cyclical variations can be eliminated from this method. And so that the only component to which the time series is exposed is the seasonal impact and irregular component. So that's why this method becomes very popular, because it can eliminate trend, it can eliminate cyclical variations, and can isolate seasonal variation. Actually, irregular component influences this time series after going through this method, but irregular component actually no one can predict it. And there might be a time series where for a long period of time there might not be any irregular fluctuations. In that case, this will hold very good. And even if there is some irregular component, well, that is really difficult to eliminate. Anyways, so let us look at the process, and then we'll also see the computation. We first calculate the centered moving average to eliminate seasonality. We express the original values as percentage of the moving average values that we get. Arrange this percentage season wise and calculate seasonal indices by averaging this percentage. So method is steps are very clear. Means, so you first do moving average. Well, we have studied it in earlier videos on time series analysis, that how to compute the moving average. Then we express this moving average values as percentage of the actual values, and then arrange the data season wise, and then just go for the average over the number of years if we have. So that is the process how we are to deal with. So let us look at some computational aspect. Say here we have a data set, and you see there are 4 years, 2018, 19, 20, 21. And we have taken the data in a quarterly basis, Q1, Q2, Q3, Q4. So this is the data set that we have. Our purpose is to find out the seasonal indices, and in case there is a trend, the trend is to be eliminated. So we look into the ratio of the moving average method for reaching a solution to this particular problem. Let us see how we do it. So entire computation is done, but let me explain to you step by step. We basically arrange the data in this way. This year we write here. In the first column we write the year. This one, this one, this one. Here we write here. So, and since we have quarterly data, so we under each year in this column we write the quarter Q1, Q2, Q3, Q4, Q1, Q2, Q3, Q4, like that we go on. Okay. In case we have monthly data, then you'll write January, February, March, April, like this up to December. That means, and corresponding to a particular year, there will be 12 months. And then these are the values: 75, 60, 54, 59, 86, 65, 63, 80. 90, 72, 66, 85, 100, 78, 72, 93. Okay, this is done. Now what happens? This is quarterly data, so we go for 4-yearly moving total. Okay, 4-yearly moving total. So we calculate the 4-year 75 plus 60 plus 54 plus 59. So this is the total 4-yearly moving total. Now one problem is there that I cannot write it because I have to write it in the center. Now center is between Q2 and Q3. So I do not get actually a point where I can write this value 248, that is 248. So what I do, I write corresponding to this. That means between Q2 and Q3. Now this actually makes my calculations lengthier because I need to get it centered. I need to get it corresponding to a particular quarter, either Q2 or Q3. For that purpose, we take this. This is the total of these two values. Now when I write 507, this 507 comes corresponding to this value. Next, let us look at the next one. How did I get 259? 259 I obtained by adding 60 plus 54 plus 59 plus 86. When I add this, I get 259. Now 259 these values. Now next one 264. How did I get 264? 264 I obtained by adding the other values, like I add up. Let me take a different color pen so that I can mark it differently. Okay, I add up 54, 59, 86, 80, 65. So I write it here. Once again, it is not centered. It is corresponding to between Q4 and Q1. So to center it, I actually add with this one, write this here. So it gets centered with the Q4, 2008 Q4. This value, I add it up with the next value and I write here. So this way, I proceed. Why do I this extra step? This extra step I am doing so that I can center the value corresponding to a particular quarter. Once this is done, then we divide it by the number of quarters. That means Q1, Q2, Q3, Q4. And here you see I have added up here. And then Q2, Q3, Q4, Q1 I have added up here. So ultimately, this total, that is 507, is actually obtained by adding 8 values. 1, 2, 3, 4, 1, 2, 3, 4, and then once again 1, 2, 3, 4. You may watch that Q2, Q3, Q4 is appearing twice, whereas Q1 and this Q1 is appearing once. Nevertheless, we require to get the average, so I divided by 8. So this I called as 4 quarterly moving average. Sorry. This we called as 4 quarterly moving average. So I get the 4 quarterly moving average. So this one is the uh, total from this. It becomes angry, it seems. Whenever I touch that area, resume slideshow. Okay. So that's why this is divided. So I get 63.375. Similar way, I actually divide 523 by 8 to get this, 537 by 8 to get this. Now, this is the moving average value that I have obtained. These are the actual values that I have. This column is giving me the actual values of the time series. This is the moving average values. Now look at this, what I am doing. So this value, that is the actual value. I will not get moving average or ratio to moving average value for first 2 quarters because I could not, because the method of moving average is such that you will not get some values at the beginning and some values at the end. So I start from here. So what is this actual value 54 divided by this value, that is just now what we obtained 63.375. So 63.375 into 100 so that is 85.21. Then I have this one, that is next you see 59, that is the actual value divided by 65.375. So I get 90.2485. Next value is 67. So what I do, what is the actual value? 86. 86 divided by 67.125 into 100. So I get 128.1192. In this way, we proceed and we actually obtain all the values of the ratio to moving average. So you might once again, let me tell you that I am not getting the values for the first quarter and second quarter of the year 2018 and third quarter and fourth quarter of 2021. Which values? Ratio of moving average method. That ratio value I am not getting. Okay. Now, once we have calculated the ratio to the moving averages, we are a step ahead and go a step ahead and we try to compute the seasonal indices. We once again rewrite these particular ratios in this tabular form. Now here we will have this, from where did we have these values? Question obviously comes. It comes from the previous table, from this table, 85.21, 90.2485. You will see 85.21, 90.2485. So these are the values that we have got from that particular table. See the arrangement and try to understand how we have to rearrange the data. Once again, we take the year, but this time the quarters we actually take along the column headings, not inside the rows as we have done in the previous table. Just see once again this table. So we are using the values only in the last column. That is the values that we are using in this column. Those values we are only using, and the year we are using, year that we have got here. This year we are using, and the quarters. This information we are using. So you can see here. Here is your year. Here is your year, and here is your quarter. 1, 2, 3, 4 quarter, and then here we have and the values of this ratio to moving average method. Now, after once we have done this, now we see we have taken the average of this. This is the seasonal indices. That means average of these values, these three values. Now here you see, as we have seen earlier also, in 2018 we don't have values for 2 quarters. So values for these 2 quarters are missing. So this average is the average of three values. That means we add them up and divide by 3, so that we get this. Here also we have an average of three values. So we have add them up and divide by 3. Here also we have three values, and here also we have three values. So everywhere we have three values each. So this average is not obtained by, though year are 4, but you can see these averages are actually 3 values are there, so which are to be average. So this total, this approximately you can tell that this is the seasonal index, but there is a little bit adjustment required, because the total of these 4 quarters, because there are 4 quarters, so it should come up to be 400. If you have monthly data, then total of these seasonal indices or total over the month should come in as 1200. Here it should come as 400, but you can see it is very close to 400, but not 400, because we have 398.8, almost 399. Okay, now we have adjustment factor equal to k equal to 400 divided by the sum of the seasonal indices. So sum of the seasonal indices is 398.865. So that value we replace here, and 400 divided by 398.865. So this is equal to 1.0028. So this is called as the adjustment factor. So this adjustment factor is multiplied with the averages that we have seen earlier. That means 100 and this value 122.0687, this multiplied by this, that is this value 1.0028. Once we multiply this, we get this value. Then we have 92 multiplied by 1.0028. So this is 2.42. You will see very slight change, because this value, the adjustment factor is very close to 1. That's why not much changes are being seen, but in some cases we might see a bigger change also. Now from this we understand that the peak season is this quarter 1, because quarter 1 is having the index more than 100. However, the lean season is in quarter 3, because it is much below the average. The average value is considered to be equal to 100. That's why we do the adjustment, so that once you do the adjustment, it will easier to understand where is the average, and we make the average come to 100, so that be above 100 and below 100 makes us easy to decode the matter which is happening over the season, so far as seasonal constraint or seasonal fluctuations are concerned in a time series. So this is how we do computation with the ratio to the moving average method. In case you have monthly data, very good. Monthly data gives a better view of the seasonal fluctuations, and we can be that can be more useful for a business decision making. We have seen quarterly data, or we have shown quarterly data, because quarterly data is computationally easier and easier to explain over a PowerPoint slide. But you have 12 months data, then it doesn't matter. Instead of Q1, Q2, Q3, Q4, four values, you will have 12 values there. And there you can take the moving average as four values. You can take time period 4, as we have taken here. So it doesn't matter. You can take 4 because you need to have a multiple of 3 there. You can take 4. There you can take 3 also. If you have 12-month data, you can take a 3-point moving total or 4-point moving total. It should be multiple of a year. That is the thing. Here you see we cannot use 3-point moving total because there are 4 quarters. So if I take 3-point moving total, the season gets fluctuated. First 3 I add, then I get a value. Actually, that is the sum of first, second, and third quarter. Then once again I take the next 3. That means we get second quarter, third quarter, and fourth quarter. So in fact, we cannot go ahead and make a statement, clear statement. So that's why we have taken 4 at a time and got 2 columns. But if you have 12-month data, you can go for 3-point moving total, because 3-point moving total is computationally easier, because 1 column less you have to compute, because it gets automatically centered. For example, in this case, say this is, let us assume that if this is what is that data of monthly data. Say in that case, if I go with 3-point moving total, then I will add this and write here. So automatically the thing is getting centered. You don't have to do an extra step. So this value divided by 3, you can get here the 3-point moving total corresponding to this Q2. Q2 you can get the moving total, 3-point moving total, 3-point moving average. So that way for yearly data you can go for 3. If you want to do that, no, I want to means no, I want to get a more smoothened values, then, or if you believe that the quarter actually spans, or the season actually spans over a period of 4 months, if you are sure with that, then you can go for 4-point also. So that is the flexibility that we have in case of 12-month data. Okay. We have already done this. We have proceed further. Let us look at the merits and demerits. This is most accurate and most widely used method. Definitely, ratio to moving average method is almost always used in studying seasonal fluctuations or seasonal indices, because we can do it very quickly. It is easy to understand also. You can do it both manually as well as with the help of packages. This eliminates both the things like trend, and can actually cyclical variations are there in the data, that also gets eliminated. It can handle non-linear trends as well, and it is suitable for most business applications. Now, non-linear trend is something very difficult to handle. Means if you go with the previous method, that is ratio to the trend method, there it becomes very difficult. Because first of all, you need to understand what type of non-linearity is there, whether it is exponential, logarithmic, or polynomial type of non-linear relationships. But here you don't have to understand what is the type of non-linear relation. You just go on with the method, and that will automatically fit to a non-linear trend if available, because trend ultimately gets eliminated. These demerits of this method, you have seen that we are getting, no, we are not getting data points at the beginning and at the end. So this is one difficulty. Computationally complex, I don't seem it is so much complex, but definitely it is little bit complex compared to the simple average method. But simple average method once again cannot handle a trend if it exists. Now, people may choose different time periods for doing the moving average. There is no objective method of determining the time period of a moving average. This is not a correct statement. Objective methods are there to determine what shall be the time period for a moving average method, whether it should be 3 years, 4 years. But that is another story. That is another group of computations you have to only to determine that what should be the period of the moving average. So that actually makes the system complicated. If you include that thing, that what shall be the time period of the moving average, then this becomes computationally really complex. Otherwise, not so much. And it requires some amount of historical data, because I require data for a long period of time. That will give me better estimates. Anyways, any method, if the data set is for long period of time, it will definitely give you better average. But one thing is there, if you take very much historical data long back, then many things changes, economy changes, tastes and habits of people changes. So if your time series is affected by these things, so having a big historical data running to 10, 15 years would not be a very reasonable choice. So this is basically the relative merits and demerits of the ratio to the moving average method. Lastly, we see the method of link relatives. This is useful when trend is present, but computational of moving average are cumbersome. Cumbersome in a number of ways, because first thing is that even your objective method of determining the time period, 3 year, 4 year, 5 year, 7 year, or 3 point, 4 point, 5 point, 6 point, 7 point, etc. I should not take year, tell year, because in this seasonality, we generally call point, 3 point, 4 point, 5 point, like that, because it may be weekly data, monthly data, quarterly data. I don't know what type of data. Okay, so there then suppose some time series are such that it is very difficult to identify what shall be the time period, because we don't go to a unique solution. So in such cases, computation of moving average becomes difficult. Or say, the data set, I have data set for last 5 years, but in last 5 years, drastic change has taken place in the economy because of certain changes in the economic policy or certain irregular fluctuation, which had a long impact. Like say Corona, even after Corona, we have seen that there is a long impact on the economy due to Corona. I am not speaking about the share market only, but it had a lot of impact on the economy. And it lasted for some time. And Corona came repeating. It was in 2000, then once again it came back in 2001. And 2001, it was to certain extent more serious also, because there was a breathing congestion when actually oxygen was running short. And then we had also in a return of Corona in 2023, though by that time vaccination has taken place and it was not so severe, but then the ghost remains. So whenever there is someone listen hears the word Corona, the ghost of 2020 remains. So even 2022 also there was certain impact was there, but then it had some impact. In such cases, your method of moving average might not be an appropriate method. We need to look forward for some other method. So here comes the link relative method. First, we calculate the data. If we have quarterly data, we calculate the link relative. That means current month or current quarter's value divided by previous quarter or previous month value multiplied by 100. Average these linked relatives for each quarter. Convert the chain relative to fixed relative and then adjust to obtain seasonal indices. So these are the steps which are used, followed in case of the method of link relatives. So link relatives computationally really very cumbersome. Step by step computation is to be done without the help of a package. Not that computation cannot be done. We have done these computations manually also with the help of a calculator. But well, this is not very much suggestive. But there are cases when we need to go for this. We have a relative merits and demerits also. That this is a simple chain-based approach. It is preserves sequential relationship. Sequential relationship means there is an impact of the previous quarter or previous month on the current value. So sometimes there is a lag of things. That means what happened last month might have an impact in this month also. So these things can be negotiated with the help of this link relative method. It's good for a short series. It is easy to update with new data. Now this is an interesting step. Suppose I have data till 2025 December. Okay. Now after 6 months, you come up that, sir, now I have data for another next 6 months also. Now including this information in other type of studies, say ratio to trend method or simple average method, we have to do the computation afresh. But in case you just can add this value and you need to do the additional computation for only for that part of the data. So including new values in the data set. Later on, after the link relative method is been computed, it is little bit easier to do than the other methods. Now, demerits, we have, let us look at the demerits. The chain effect can magnify the errors. So, sometimes there is a chain effect, so errors get magnified. The error that existed in the previous month might have an impact on this month. And this month's error will have an impact on the month coming up when we actually express them as a chain index.
it is difficult to interpret the final indices. Now it is less popular because it is only used if moving average method cannot be applied due to some reason. So already moving average method has become very popular, and most cases it is found that it can handle. So this relatively becomes link relative method becomes less popular, and it is unstable with volatile data. There is some instability in case your data is volatile. So volatile means a lot of fluctuations over a particular season. There might be a lot of fluctuations in the data set. Now these cannot be managed with the help of this method of link relative method. Now we compute the seasonal indices. Whatever be the method, whether it's simple average method, whether it is the ratio to trend method, whether it is ratio to the moving average method, or the link relative method. Ultimately, for each season, we get an index. Or if it is monthly data, we get 12 indices. If it is quarterly data, we get 4 indices, and so on. Now, how to interpret these indices? Already we had discussed that if the index value is 100, it means that the average performance of that period or overall average of the year is been handled by that particular month or that particular quarter. Here we don't require to have any special action because already the data will be at the average, and all business professionals are actually having a system which can do well when the values are on an average. Now, if the value seasonal index is more than 100, it indicates that there is the existence of a high demand or maybe the peak season. Now, in that case, we require more stuff, we require more inventory, we require more of the marketing, we require to be up and doing because there will be a huge demand or a pressure on the organization. So we have to be ready for those particular seasons where the index value is more than 100. If the index value is less than 100, it indicates an off season or a lean season where the demand falls below the average. In that case, we may transfer our staff to some other place for doing some other type of work, or we can actually eliminate those employees who were hired for a particular purpose. That is temporarily hired, they can be transferred, or they can be scrapped from working from that or in that organization. And we can actually, this is the time period when we can control our cost, because lean season means less, everything is coming less demand, less of production should be done beforehand. So this is how we interpret the values of the seasonal indices. Now let us look at the important takeaways from these for the business leaders. First is that the method of simple averages, that is the simplest method, and the trend is present, then we can go with the ratio to trend method, which actually has some computation issues. And for comprehensive analysis and the most popular method of studying or computational of seasonal indices is the ratio to the moving average method. And if you want to, if you believe that there is a chain of previous month or previous season is having an impact on the next season, and this is happening year after year, then you can go with the link relative method, or in some cases, when the ratio to moving average method is not appropriate, but there is a trend is present. Okay. So these are some additional steps in the next few points, which we had not discussed in detail during the entire presentation. Means whenever we have a time series, first draw the graph of the time series. That means you take along the x-axis the time and along the y-axis the production or whatever profit, whatever you are going to study or demand. So this will give you an idea of understanding whether there is a trend in the time series. The trend will show an increasing trend or a decreasing trend, or maybe also the presence of a cyclical trend, like whether there is a growth and fall after a long period, like 5 years, 7 years, like that, or the seasonality, impact of seasonality, and the existence of irregular fluctuations. So once you draw this time series graph, that means values of time along the x-axis, whatever value may be, the time may be yearly, monthly, quarterly, daily, weekly, whatever you have, you just plot this graph. This will give you an idea about how the time series is moving, whether their existence in trend, whether there is an existence of abrupt rise and fall, this type of things, and then you can understand that which, if you are interested in computing seasonal indices, you will understand that which method would be the best method for my type of data. Uh, Now, whenever you have these seasonal indices, suppose I have some historical data, I have compute seasonal indices. So I can check whether this same pattern is followed in the recent years as well. So this is a common practice because with the advances in data science or with the data science becoming more popular, validation of a result has become very important. What the data scientists generally do is that they bifurcate the entire period into two parts. One part they use to estimate the seasonal indices or find the value of seasonal indices, and another part, say I have data for 12 years, monthly data for 12 years. So what I do is that I use 9-year data to calculate the seasonal indices in any of the method. And then I see that whether the indices of this data set, that is 9-year data, is matching with the seasonal indices of the next 3 years. And that way we can also compare that which method is the best. Though there are other methods from the graph itself, we can get an indication that which method can be more applicable. But this is another way of validating the results. It means I divide my time period into two parts, one bigger part, one smaller part. Bigger part is used to estimate or calculate the value of the seasonal indices, and the other smaller part that is used to validate the result. That means we check whether the results obtained are in keeping with the next 3 years, which we have not considered while developing the model. So this information will help us to update the seasonal indices. Also, suppose now I have computed a seasonal index and I know that, okay, well, July, August, September, these are the peak period, and then October, November, December, these are the lean season. I understand this. Okay, fine. Now, once 1 year goes, that means now we are in 2025. After 12 months, we will be in 2026. In that case, I can utilize that data and update my result. So that is what a business professional should do. Not that, well, I computed these things in 2024 and this is the result. So let us continue it for 5 more years. Not like that. Every year you have data, every quarter you have data, every month you have data. You can use that and you can update your indices. So this is a very good practice. So I would like to thank you a lot for watching this video and hope to see you once again with some other video in this channel. So I request you to kindly like, comment and subscribe to my channel. Thanks.